This is Norma Walsh and this is my video on the mean proportion. So to start off, I'm just going to show you how to get the mean proportion. We'll just take an example of a 9x4 rectangle. So if you sketch out the rectangle, this would be roughly 9 units and this 4. Where we start is, we continue on this line and then using this point here as the center point, we swing an arc. So from here to here is now 13 units. So our next step then is to find the center of that. So if we take the center to be roughly here, which would be 7.5 units, and we'll swing an arc. Then what you do is you continue on this line up here and carry it across and carry it down, and what it should give you is a square with the length will be the mean proportion. So this will be 6 and this will be 6, so the actual mean proportion is 6. And if we just show you how it works, it all works in terms of ratios really. If I give these points letters, this will be A, B, C and D. So as you can see now, BC is to BD is the same ratio as BD to AC, because say, look, if we put down their numbers, maybe BC is 4 units, which is the same. 4 is to BD, is to 6 is the same as 6 is to 9. And really, this all works because it forms 3 triangles, and the 3 triangles are all similar triangles. So just for example now, I'll join them up and show you. This here is one triangle, this here is another triangle. So say ADB and DBC, and then the other third triangle is ADC. So if I just draw them out over here on the page, this can be ADB. So this is 6 units. This is 9 units. This is also a right angle. And then if we take this triangle, which can be DBC, this is 4 units and this is 6 units. And then finally the large triangle, this is ADC, and this is right angle and this is right angle. So if we examine these triangles, they're all similar. Sorry, I'm just writing the lengths here. This is a length of 13. So they're all similar, like they all have a right angle, and these angles will obviously be the same as well, but they're all different lengths. But how it works is the lengths are in the same ratio. So we know this angle has to be a right angle because any angle in a semicircle is always 90 degrees. This comes from the theorem where the angle at the center of the circle is twice the angle on the circumference. So say, you know, here this is a straight line, so this has to be 180 degrees. So half of that is 90 degrees, so we know that has to be 90 degrees, and we obviously know these have to be 90 degrees because they're perpendicular. So that's really the concept behind the mean proportion. Like, you can calculate it mathematically as well. So say for example, like we started off with our 9x4 rectangle. By 4. So what we could have done to get the mean proportion is put 9 over x equal to x over 4, and if you cross multiply, you get x squared is equal to 36, then x is equal to the square root of 36, so then x has to be equal to 6. So that's also another way of calculating the mean proportion. But really the main thing to keep in mind when you're doing it is that the sides are all in the same ratio and it's based on similar triangles. So they're the main points, and thank you for listening.